Yep.
So, hello again. It's really nice to be here. Actually, it's my first time having talk online. I assume it's all for you as well, but I'm super excited. So, I will start by saying that the idea for this talk came to my mind when I first joined Twitter a few years back, and it was the same time I started using React Native a few years ago. So back then, I immediately start following React Native hashtag and all the relevant people from the community out there. The guys from Facebook and the community as well. I mean, all the developers that using React Native project. And from the moment I joined, I found a new sarcastic world. I felt there is so many bad vibes around React Native in the community. Some of them talk about performance, some of them about the architecture. For me, at the beginning, it was pretty clear that from all the tweets that React Native won't be ever like real native application. And as you can see, there are funny ones, funny tweets. And one of the complaints that I keep hearing here and there is that as a big company, or if you have a big mobile application, React Native is probably not for you. And guys, it's just wrong. And I want to give you a brief overview about our case in Wix. So let's start by taking a typical company. At the beginning, it was pretty easy. It was super fast, small company, great team, small amount of developers. All of them probably work on the same repository, sitting in the same room. You are able to manage the development process in such way that you develop one feature and it's not interfere for other one, and you don't break his model. But from day to day, you realize that as you grow and things got more complicated, and you change the structure of the company, and you can't work the same way as before. As your company grow, your app grow, and you have more features, more developers join to the team, and it's indeed became more difficult to build a React Native application with such an architecture, simple one. And to be honest, it became impossible to work on the single repository. 100 developer, 50 developer, even 10, it can be complicated. And I have to admit, it's much more complicated with React Native because we are working on 3 different environments. We're using Visual Code or Android Studio, Xcode. We have to deal with NPM, which all of us really like, of course, as well as Gradle, Maven. Now we have to use CocoaPod as well. So it's not an easy one. You feel like it's all actually affect your performance, builds super long, you have conflicts from hell, everyone break each other code, and there is a huge mess. It feels like this for us too. And well, suddenly you understand that you hit scale and you need to change the way you think. And today I'm going to talk about something that most of the successful mobile app will deal with somewhere in the app lifetime. It's called scale. And scalability is an attribute that describes the ability of a software or organization to grow and manage increasing demand. And when talking specifically about how to scale mobile solution, we can speak about scalability in two things. One of them is growing customer base and your app ability to handle the volume of the users. And the other one is the hardware infrastructure and the code itself, how you can manage to do things much faster and not like before. So hello again, I'm Omri. I'm from Tel Aviv in Israel. I'm currently lead the mobile platform at Wix. And today I'm going to guide you how to scale your teams for React Native application. Of course, you can find me on Twitter, Omri Bruchim. I'm not one of the coolest guy here that have a nickname, just my name. And originally I came from iOS background. When I joined Wix, JavaScript was new for me. And today I'm mostly around React Native application, focus on the architecture and the performance of the application. And today we're going to have a case study together about Wix. I'm going to give you a brief overview about Wix mobile application story. I'll define you our problems and how to solve them with some secret sauce. And at the end, we're going to discuss whether it worked for us or no. The answer is pretty clear. So let's start. If you're unfamiliar with Wix, Wix is a platform for creating a stunning website and to manage your business. With the Wix mobile application, our users can manage their sites and businesses on the go. For example, if you have a restaurant, and let's create a website in a few clicks, and you get orders and reservations and invoices through the app and much more. And if you have a yoga class, no problem, define your services, allow members to book services, and they can pay for the services on the app. We currently serve at Wix more than 150 million users around the world. Well, Wix started its mobile journey with React Native back then, 5 years ago. To be honest, we took a big chance with React Native back then. It was super promising, and we decided to go for it. And today we are happy about the decision. Our application today is huge. It's important to say that we start with React Native from scratch. We started around the production 3 years ago, but with development much before. A lot of screens. We release 2 versions, both for iOS and Android, every week. We are around 100 mobile developer, and our crash rate is super low. So let's start by overview our problem. Let's talk about scale. What is scale? Scale for me is the ability to grow without compromising on development velocity, and on the other hand, increase the velocity without compromising on product quality. If you don't understand yet what is the problem is that we want too much. We want to grow, we want velocity, we want quality, but in other words, we want to be able to increase the teams and the developers, release more features, and all of this without affecting time to production and without affect the quality of the code. And you want all of this to be fast. From the small team to huge group, it's double trouble because it takes time to scale your application and your code base. You maybe need to change the architecture like we're going to do today. If you are wondering what the hell is he talking about, so let's drill in a little bit more and see some examples. I want to take a typical React Native application and review the architecture, and then we see if it suits our needs or not. So at the bottom, we have the native SDKs, iOS, Android, you have Windows. I know you have web as well, but in our case, it's iOS and Android. In the upper level, you have your application business logic. It's included, it's written in JavaScript with React, and this is all the business logic, your screens, the code itself, the fetch to the server, and all the rest. At the middle, you have the React Native framework. It's where you talk between the JavaScript and the native SDK. You have the Android native views and the iOS native views. You have the APIs itself of React Native with Metro and all the rest. And if you want to extend your APIs, I mean, let's take, for example, you want to use the camera, you maybe want to use the camera kit with open source that's written especially for React Native. So you add it as a dependency. And at the end, we have the JavaScript code and the JavaScript library. We have JavaScript library that is like Lodash, Moment, and any other code that you have. It can be shared code with the web as well. So we did it super fast. This is the architecture of every simple React Native application that you start from scratch. Most of the time, all these dependencies are in the same repository. I mean, you have one repository and with the dependency for React Native, for React, for all the React Native third libraries and the JavaScript libraries. And the problem is this architecture is pretty hard to maintain. But there are more than 10, 20, 30 developers working on the same repositories can be a mess. And now a lot of people will say that you can move the JavaScript logic outside to separated libraries, but the problem with it that at the end you want all the developer to work on the same main project. You want them to have the same native dependency. You want to work on the same React Native version. So if I have a bug, I want it to be the same environment as production. And you can do it if you go to the JavaScript code outside and have React Native as a dev dependency. It's kind of a problem. For us, it was a chaos. Why a chaos? Let's review the problem. First of all, it was the ownership. Because we are working on the same repo, there is no well-defined ownership. Who is owner of this part of the code? And even if you're working on a mono repo, it became huge. It became a mess. As a result, it's caused a slow development. And because we need to build the whole native project every time you change a piece of code in JavaScript, and it's not necessarily. It's super hard to test the code. I test the code in my environment, it works, but just before I release it to production, it broke, and I don't know why, because my environment is different from the real one in production. It was really hard for integration. Doesn't matter if you have one repository, mono repo, a few repository. It's really complicated to make an integration and find fixing bugs. Local production are different. We already talked about it. React Native upgrade. Funny, huh? It's a nightmare because you need to stop development, ask everyone to start and fix their code, and then you can release it. Anyway, we had to change the architecture of the app. And we had other problem. Let's take, for example, the loading time. This is a screenshot of our logs. You can see that from time to time, the startup time of the application got increased. Each one of these bullets is a new release. And from time to time, the startup time increased, and we didn't know why. We didn't know why because we don't know who is responsible for this code. We can't measure each team separately. So we decided to scale and to change the way we think. Now that you got much more sense of what the problem was, let's try to solve the problem. When you design an architecture, it should fit your organization structure. In our case, Wix is divided to multiple entities that we call them companies and verticals. These are product-oriented entities working on a set of features for specific product. For example, as I mentioned before, we have stores, we have blog, we have chat. Each one of them is kind of a small startup inside the big company. And in addition, we have the professional entities that called guild. We have the server guild, we have the Fed guild, and we have the mobile guild. The guild is responsible for aligning all the developers in the company and when it's needed. And the idea behind this structure is to make sure that we are able to move quickly. Each one of these companies or small teams can run quickly. They have a different release process. They can have different dates when they ship features to production. And we don't want to interrupt each other. In terms of goal, when we think about re-architecture of what we are doing, we want to have an independent development. Each team can test his code independently with the same infrastructure. It's important. To emphasize the problem, I want to think about two teams. One of them working on React Native 61 and the other one with 62 because they don't have the same infrastructure. So maybe one of them has a bug and the other one won't. Wix is a web-oriented company. So it means we have much more web developers than mobile developers. And we want to achieve a beauty that not all the developers need to know React Native or native. You know that developing in React Native not necessarily mean that you don't touch the native code. It's just in theory. You need to handle the projects and the iOS and the Android project and CocoaPod. We want to get to a place where the developer no need to touch any native code. Independent deployment, each one of the team release production as much as possible. We want to run fast. We want the same production dev environment for all the developers. It's easy to see it's like an OS and application, like Chrome extension and Chrome, like an application in iOS and the iOS itself. we want to have an operation system for all the teams at Wix. So back to our simple application. What we want to achieve, it's not really possible with this structure. It's like, think about all the application in iOS, all the iOS apps work on the same repository or the same code base. So when we think about it before, the key for success in our case was separation of concerns. You can think the backend developer, they call it microservices. In the front end, it's sometimes called micro front end. The separation can be on a different ways, vertically by features, horizontally by layers. We can separate the React Native layer from the application business logic, but we decided to make a match and do something that suit our needs. So let's start and change our entities and make a new order. First, I want to split the higher level, the application logic with JavaScript and React. Actually, most of our code is written with JavaScript, so it's not making any sense to put all our code in a single project. So I split it to two parts, the infrastructure part and the product business logic. If you remember, I told you that we have a lot of teams that created the product, but we have other teams, or actually less than that, one big team that is write the infrastructure. The infrastructure is written with JavaScript as well. So let's focus on the product business logic. Because it's written by most of the company, a different team, we can even split them into a smaller part. Each group want to work independently, so let's split them. We split it into something that's called module. Let's really understand what is module. We currently have more than 35 modules in the application. Each module, again, it's a different team. It's developed by a different team. So module is a mini Wix app inside the big Wix application. It's easy to think about it again like extension to the application or an application on the operation system. Each one of them has an independent encapsulated product business logic. It's not related to each other. Modules is written only in JavaScript. There is no native code, and it's one of the constraints or we see it as a benefit, but it's not necessarily have to be relevant for you as well. Modules, of course, can communicate with each other because we have teams that depend on each other. We have teams that create the payment, and we have other teams that create the restaurants. So probably the restaurant team want to use the payment APIs, so it's possible. And each module implement an interface. We are going to see it in a few minutes, but it's like if you are a module, you want to tell everyone that you expose something so they can use it as well. So we're done with the product teams at the top. Now let's focus on the left part, on the infrastructure team. So the infrastructure team is responsible for the infrastructure code in JavaScript, and the upgrade of React Native. It's included all the React Native itself. We took all of this and put it in something that we call the engine. So let's see, what is the engine? The engine is the entry point of the application. When the app opens, the first line of code that is the app.js of the engine. It provides an infrastructure to all the modules, and they can focus on writing the products, and we as an infrastructure team develop all the infrastructure APIs. For example, the push notification handling, if you use localization. It means that the engine includes all the native dependencies and React Native itself. It's important for the next bullet because we want to have a place, a repository that includes both the iOS and the Android binaries. This is actually the most important part of the architecture for the whole talk. The engine actually holds the binaries of the application. So we're gonna see later how it's look in real application. But for now, you can think about it as kind of an expo. That's you use expo and add only your JavaScript code. actually JavaScript code is isolated for the native code. So why can't we compile it in advance and on separate repo from the other code? And when I want to ship my code, I don't need to build over again all the binaries for iOS and Android. We're gonna get back to it later. The engine is the one that's load and run the modules by config file. So I just need to tell him, the engine, what is my module, and he just need to expose something that's called module.js. We're gonna see it soon. And the engine open the module and run itself. The engine holds all the infrastructure code, as I mentioned before: push notification, error handling, network accessibility. So we develop all this infrastructure beforehand, and the module can use it when it's ready. The engine is kind of module, but just a different module that's used with native code and the JavaScript code itself. And the engine is developed by a single infrastructure team. This team includes a really strong native developer, so it's easy for them to do something in native project. So we're done with the product business logic. We're done with the infrastructure. What's left? What about code sharing? So we left with the JavaScript libraries. So JavaScript libraries is basically common code between modules. It can be a common code between mobile and the web, between the modules, and it can be open source if possible. But you can remember that module can have a dependency to a JavaScript module, to a JavaScript library, just because it's part of JavaScript code. It's not include any native code, so it's not have to be inside the engine. And open source is possible just because, by the way, we really like open source things in Wix. We big fans of open source. As a rule of thumb, a few years back, when we started to create React Native application, we decided that every piece of code that is non-Wix related code should be open source from the first commit. Meaning everything that is not the business logic for Wix is open source. Working with Scale with React Native teaches a lot, and we would like to share it with the community. One good example for it is React Native UI, and as well as React Native navigation and detox that you're probably familiar with. React Native UI is a mobile design system for Wix, a constant UI and UX all over the application. It's improved our velocity and has fast delivery and weekly releases. So that's all basically. That was the original structure of small application, typical application with React Native, and we changed it a little bit. We leveraged the Wix organization structure, so we opened the app to many other teams and allow them to build and maintain their own part of the application. It allowed them to have freedom on one hand, and unified product, UI, and APIs for all the application, even if developed by other teams. So let's see how all these entity work play together. In fact, our repository that is being released to Google Play or App Store is just a configuration file and list of dependencies. It doesn't contain any line of code. The configuration file includes the engine itself, the repository, and list of modules to be loaded. Now the engine knows which module to load, and that is the interaction between module and the engine. So you can load all the modules one by one, only if necessary. It can be a lazy loading. And the line that you can see is that because modules can interact between themselves, but it have to be through the engine. The biggest change we did is to take the pre-built native image from outside from the main repository into a separate project, just because we want to have, again, something like similar to the concept of Expo, but tailored specifically for Wix. So we took the APK and the IPA and put them inside the engine. So if you want to run only my module with the engine, I can do it, like a black box. It means, again, each and every team getting the same native environment and no need to touch any native code. it saves build time and solves native integration issues. Let's read in and see what is a module. Module include source file, all the screens, business logic, resources folder, and module.js. Actually, let's see an example. I want to show you a typical module and how it should look like. So this is an example for the main repository, as I mentioned before. You can see that there is no source code folder here. There is no source code in the main repository, only one file that is called engine auto-generated that include all the modules themselves. This is all the modules that we have in the code. And the package.json. The package.json itself include all dependencies. That each dependency is another module. Each module that has a different release process, and we bring it as GA. And you can see that it includes also the engine. The engine is same like simple module, and we bring it as GA. It's basically allow us to have a different release process for modules and the engine. We release the engine once in 2 weeks, can be 3, because it's all the native code. And modules can release a new version every day or twice a day because it's only JavaScript. I can elaborate it more later, but it means that we can actually release the JavaScript code over the air and not through the Play Store on the App Store. So now we can see the engine itself. The engine is, again, like a typical React Native application. Its structure is a little bit different. You can see that it's include the source code inside the code. The most important part, you can see that it's include the app builds. It's hold the Android APK and the app of the iOS application, and of course all the source code. It can hold all the logic itself. Package.json of the engine does not include any module because it's agnostic to the modules. And now we can see an example of one module. It's called the platform. The platform or a module need to have 2 important files. One of them is the package.json. You can see that in the package.json, we have pre-dependencies for the engine. You should have it as dev dependencies as well. And you can have, if you want to, another modules, because probably the platform module is interact with the rich content module. So they want to talk with each other in development environment. And if you want to see where you can see that there is a source code with all the JavaScript code, but there is no native project here. So how we run the project? So if we go into the node modules, it will be easier to see it on the main repository. It's called OneUp. If you go to the node modules and look for the engine itself, we have the engine project, and the engine project holds inside the app build, as we saw before. So basically, it means that this repository trigger the JavaScript entry point from the engine, and the engine is responsible to load all the other modules. In the package.json of the platform, I need to tell him which module I want to load. In that case, because we are in the main repository of the app, you can see all the modules here. But if we go back to the platform, its specific module, in its package.json, you probably see only a few modules. And it can be a demo modules, a module that's not going to production and just I want to run them in development. But you can see this, I want to load myself as a platform and maybe another model because I have an integration with him, so I want to check it in debug. Let's go back to the presentation. So basically, module have the package.json module. It's include set of function that is actually the API, the interface with other modules. I want to show it again. Let's go for we are in the platform, right? Let's jump into the source code. Each module need to have specific file called module.js or module.ts if you was TypeScript. And this file is actually what I said before, is the interface with the engine and with other modules. So it had the init function that you want to init whatever you want. It has component, methods, it should have tabs because we have tabs in the application. So each module can expose tabs. You have handler for login. If I log into the application, on app switch to foreground, basically we expose whatever module need. We can take a look of the methods. So it's a set of methods with specific prefix and code that you can execute, just like interface in other high-level application. I go back to the presentation. So we saw what is module. We saw that module can load itself only with the engine. It can have loadation moments as dev dependency only as a dependency because it's only JavaScript. And you can see that I can bring other module, and it means that I have an environment only with me and the other module. It's pretty amazing. This way, module can interact and have an integration with different modules and check the APIs before they go to production. And we saw the engine hold the APK in the app itself. We release the engine every 2-3 weeks with a full native optimization, improvement, something like React Native upgrade. And the main repository only include the modules and the engine themselves. So basically the development process is you push code to the repository and build the test it and publish it as a GA. So you don't have to have nothing with the main release process. Few words about the communication between modules. You saw that the communication is through the engine. There is no direct communication. Engine is as a proxy because we want to understand who talk with who and analyze the performance. We have no direct or input required between the modules, only through the engine. We have contact validation. It's much more scalable. We have 4 levels of communication. You can read about it more in a blog post that I'm going to share in the upcoming weeks. But it's kind of our kind of communication. We have component. You can get component from another model and show it on your screen. You can use other module method, and you can register for events for other model. For example, we have module that's called notification, and you want to subscribe for a new notification in the app. And we have something that's called service that is like broadcast, but a little bit different. That's all. I cover a lot. I know it's a little bit complicated, and it's take time to understand, but it's make a lot of sense for us as a huge company. And it brings us to the end of the presentation for the big question. Does it really work for us? So of course, yes. In terms of goal, we got all what we want. Let's see. We got an independent development. Each team can be tested as a black box. You can change the dependencies of interaction. We have an independent deployment. As I said, each module can share can release whatever he want. We have web developer we write the modules themselves in JavaScript. They can be a web developer and not have to be native expertise. We run fast, really fast. We have the identical environment for dev and production, and we like operation system and application. Now React Native upgrade is much easier. In fact, in the last upgrade to 62, just because we want to use Hermes, we want to upgrade to the latest React Native, and we did it only in the engine. We just released a new engine without any breaking changes because we fixed all the polyfill and the proxies and let's say we use a proxy for a polyfill for proxy. So for the model, it was transparent, this upgrade, and do it in 2 weeks. We have a clear API between the teams, and we have a different release process. I'm not going to elaborate it because we need time for another presentation, but basically, if I change my code into JavaScript side in the module, I can ship it to production without going through the App Store, only over the air with code push. And the last one that we are working on, we actually can load module by lazy. It means that I don't load the module until I need to, and it can reduce the startup time and can reduce the memory consumption. Taking into account all of the above, it makes sense to have mostly engineer with front-end skills and not with the native. So it's a huge advantage. And that's what I talked about, the release process. It can be over the air or all the rest. So to wrap up, we know that we are one of the biggest React Native applications in the world. We have 100 developers. They spread over 5 sites in 3 different countries. A lot of groups and growing. Most of our code is JavaScript, and we have few native developers as well, mostly in the infrastructure teams. Rough estimations, 85 of our code is shared between iOS and Android. We have a lot of code shared between the web and the native, because each team is responsible for the web part as well as the native part and the mobile part. And we're able to release a production version actually every day. We do it three times a week, but we can do it every day. And we have millions of active, and I hope they're happy users. That's all, and don't be shy. If you have any question, you can ask me now. I'll be happy to share. That's all.
We have a question from Finn. It may be a bit of a tangent, but it's easy to see how the separation of concerns is split in different teams, but how do guilds organize and share knowledge? How do your guilds
so
organize?
If I understand the question, let's say we have the Fed guild that developed the code for the web part, and we have the mobile guild. We have kind of share between the guilds. We have tools that we use for both guilds. It's not totally separated, but you need to understand that as a mobile developer, we have something that's most interested. The mobile developer interested in such other things like React Native presentation. Let's say we have a new library for React Native. It's have nothing to do with the Fed. But we as a mobile developer have a lot of interest in the thing that the Fed doing. So sometimes we have something that's called Guild Day, once in every 2 weeks. So all the mobile developer go to the Fed mobile guild, the mobile Fed, and interact with them and see the presentation. So there is kind of sharing between the guilds. It's not totally separated.
Do you have any plans to open source your engine or module architecture system in any way?
It's a great question. Basically, we thought about it at the beginning, but it was a little bit complicated because the engine includes a lot of business logic, but it made a lot of sense. It's somewhere in the plans. Basically, I'm working on a blog post to describe this whole architecture, and we want to create a demo application with the engine module so you can understand how it works, because it's mostly scripts to take the native part from here to there. So it's in the backlog. We will need to do it soon.
Yeah, you could almost create simpler pieces of each system and kind of still put it all together and share that. I know that it works. What works for one team does not always work for every team, but I feel that both developers, technical leads, even managers of teams of software developers can take a lot away from this. And as a developer who's in the process of creating strategies for my team, I think I have some homework to do. Probably watch this talk over several times and take some notes. This is a great case study.
Thank you. If you have any question, any of you, or for the visitor as well, feel free to tweet me, ask question, whatever you want. I will be happy to share everything.
Absolutely. Everything?
Everything.
All right. I'll hand it back over to John. Thank you.
Thank you. Bye-bye.